Welcome back, class. Today we're going to look at section 5.1. It's called Multiplying Polynomial Expressions by Monomials. And before we start multiplying polynomial expressions, let's go ahead and review some properties that you might have learned in the past. So the first one is called the product of powers property, and that's when you're multiplying numbers with the same bases. When multiplying numbers with the same bases, for example, a to the m times a to the n, you simply just add the exponents. So that's equivalent to a to the m plus n. When dividing numbers with the same bases, you subtract the exponents. So a to the m over a to the n is equal to a to the m minus n. The power of a product property is when you're multiplying two numbers and you're taking that product and raising it to another power. A times b all raised to the nth power, which is equivalent to a to the nth times b to the nth. So it's sort of like the distributive property where you take the exponent and you distribute it in. So once again, that's a to the nth times b to the nth. The power of a quotient property is the same thing, but instead of multiplication, we are now dividing. So a over b, all raised to the nth power, is equal to a to the nth over b to the nth. Once again, take that exponent and just distribute it in. The denominator can't be 0, so b cannot be 0, otherwise the fraction will be undefined. The last property is the power of a power property. So a to the m raised to the nth power is equal to a to the m times n. Now let's look at some exercises. Explain 1a. Find the product. We have 6 times x to the third times negative 4 times x to the fourth. Let's go ahead and multiply those numbers together. Let's start with 6 times negative 4. 6 times negative 4 is negative 24. Now let's multiply our x's. And before I combine x to the third and x to the fourth, let me go ahead and write them out. That way it makes a little more sense. So x to the third times x to the fourth. Now I'm not going to write it out every single time. I just want to show you why the shortcut works and why the shortcut's necessary. Okay, so let's go ahead and take this one step further. We have negative 24 times x to the third, that's 3 x's, x times x times x, times x to the fourth, that's 4 x's, x times x times x times x. So let's look at what we have. We have the negative 24 from earlier. And then we also have our x's. How many x's do you see? 1, 2, 3, 4, 5, 6, 7. There are 7 x's total. So in other words, x to the 7th power. Answer for this problem is negative 24 times x to the 7th power. Now instead of having to expand all the x's, what I could have done from the beginning was just add 3 and 4. 3 plus 4 would give us our 7. In explain 1b, we have 5 times x times y to the 2nd power times 7 times x times y. Same concepts, multiply the numbers together, such as 5 times 7. 5 times 7 gives us 35. We also have x times x. X times x is, well, remember, because they don't have exponents, go ahead and write the exponents in. Both of the x's have an exponent of 1. So x to the first times x to the first, well, if we add 1 plus 1, we end up with 2. Now let's multiply our y's. So y to the second power times y. Remember, that's y to the first. Y to the second power times y to the first is y to the third. And so our answer is 35 times x squared times y to the third. Now let's look at a problem that's a little bit more challenging. Explain 2a. Find the product. So I'm going to take that 3x and I'm going to distribute that 3x into each term inside of the parentheses. I have 3x times 3x squared. Well, 3 times 3 is 9, and x times x squared is x to the third. Next, I want to distribute the 3x to 6x. 3 times 6 is 18, and x times x is x squared. Finally, 3x times negative 5. 3x times negative 5 is just negative 15x. My answer is 9x to the third plus 18x squared minus 15x. Let's look at another problem. Find the product. 2xy times 5x squared y plus 3xy squared plus 7xy. Once again, take the monomial that's outside and distribute it to the trinomial. So 2xy times 5x squared y. 2 times 5 is 10. X times x squared is x to the third. Now go ahead and just write in your exponents. If you don't see an exponent, remember to put an exponent of 1. And we're going to do that for each one, just so that we remember what the actual exponents are. So once again, x to the first power times x squared is x to the third. Y to the first power times y to the first power is y squared. Now let's repeat the same steps. We're going to take 2xy and multiply that to 3xy squared. So 2 times 3 is 6, and x to the first times x to the first is x squared. Y to the first times y squared is y to the third. Moving on to our last term. 2 times 7 is 14. X to the first times x to the first is x squared. Y to the first times y to the first is y squared. And that's our answer. You try number 2. Find the product. We have a monomial times a polynomial. 2a squared times 5b squared is 2 times 5 is 10. A squared and b squared, we don't have any other variables that are similar to a and b, so we're just going to leave a squared and b squared as is. Let's move on to the next set. 2a squared times 3ab. Well, 2 times 3 is 6. A squared times a is a to the third. And then we have that b that's not being multiplied to any other b variable. Moving on. 2a squared times 6a. 2 times 6 is 12. And then a squared times a is a to the third. And finally, 2a squared times 1. Well, that's just 2a squared. So the answer to this problem is 10a squared times b squared plus 6a to the third times b plus 12a to the third plus 2a squared. That's all I have for today. If you like this video, don't forget to give it a thumbs up and subscribe.